Hi, everybody. Mr. Wyatt here again. And now we're moving into topic 7.5, section 3, part B. We're going to talk about parallel lines and transversals. You know, we did discuss what happens when you have two intersecting lines and how it forms some different angles. And there are relationships between those angles that allow us to find some of the missing measurements if you're given even just one of those um, angle measurements in that figure. Well, today we're going to be looking at what's called a transversal line. And you will see transversal lines used whenever you see parallel lines. For example, here you see a pair of parallel lines. This line here and this line here are running parallel to each other, meaning they're on the same plane and they're always the same distance apart. This other line here is cutting through those parallel lines, and it's cutting through them both at the same angle. And this is known as a transversal. Okay, so that line which is cutting through the parallel lines, that's what we call it, a transversal. Okay, so much vocabulary in this chapter. It's a transversal, and I want it to be purple, but it's black. All right, so anyway, what happens? Well, you're going to see some of the same terms that we've been discussing, but I have some new terms for you too. All right, angles 3, 4, 5, and 6 are called interior angles. The reason they're called interior angles, here's angles 3, 4, 5, and 6. The word interior means inside, just like an interior decorator wants to decorate the inside of a house or a building, for example. These angles 3, 4, 5, and 6 are all inside of these parallel lines. Okay, you have these parallel lines. The ones inside are called interior. The other angles, angles 1, 2, 7, and 8. Here's angle 1, here's angle 2. I'll put little triangles around them. 7 and 8. These are exterior angles because they are on the outside of those parallel lines. Okay, so when I am talking about interior angles, you need to look inside of the parallel lines. But when I'm discussing exterior angles, then you're outside of those parallel lines. And the line that is cutting through those parallel lines is known as the transversal. And one more thing I want to mention to you before I go to the next slide. When you look here, oops, I'll try that again. When you look here at this transversal, which is passing through these two parallel lines, it forms 8 different angles. I've labeled them 1, 2, 3, 4, 5, 6, 7, and 8. Those 8 angles all have one of 2 measurements. Okay, so if I find all those measurements, it's just going to be 2 separate measurements that you will see. Okay, all right, well, I'll show you as we go along, don't worry. Lines B and C are parallel lines. Here's line B right here. Here's line C right here. They are parallel. And you can see that looking at this figure, how they are the same distance apart at every point. They would never, ever intersect if you continued those lines on forever, if you continue drawing those lines forever. So line A is cutting through those parallel lines. Line A is your transversal line. Okay, that's your transversal line. It cuts right through those 2 parallel lines, forming these 8 angles. Okay, and these angles are related to each other. How so? Well, I have more terms for you. We already discussed vertical angles. Vertical angles, remember that the root word here is vertex. Vertical angles share the same vertex and they go in opposite directions from each other, like mirror images of each other. And vertical angles are congruent, meaning they have the same measurements. So angle 1 and angle 3 are vertical angles. I'm going to state the congruence like this. Angle 1, well, let me try that again. That's pretty messy. Angle 1 is congruent to angle 3. Remember, the congruent symbol is an equal sign with a squiggle over the top of it, meaning they have the same measurement as each other. They share this vertex right here. They're mirror images of each other. They're congruent. Angle 2 and angle 4 are vertical angles also. So I know angle 2 is congruent to angle 4 because they are vertical angles. Over in this grouping of angles, angle 6 and angle 8 are congruent angles. They have the same measurement because they're vertical angles. And angle 5 and angle 7 are vertical angles, so they are congruent as well. So angle 5 and angle 7 would have to have the same measurement. If somebody says, well, how do you know? You say, well, they're vertical angles. And vertical angles, by definition, are congruent. They have the same measurement. All right, the next term that you need to know, this is a new one today, corresponding angles. Corresponding angles are also congruent. So what does it mean? Well, corresponding angles are in different groups of angles here, but they're in the same position. Like angle 1 here and angle 5. Do you see how both of those angles are sitting in the same position? They're both in the top left corner of their groupings of angles. That's known as being corresponding angles. They're in corresponding positions, okay? And I wish I could get that little box to go away there, but I'm not sure quite how to do that. So angle 1 is congruent to angle 5. If somebody says, well, how do you know angle 1 and angle 5 have the same measurement? You say, well, they're corresponding angles. See how they're in the same position? They're both top left corner. Do you see any other angles that would be corresponding? In other words, being in the same location in their separate groupings of angles? How about angle 2 and angle 6? Those are corresponding angles. So they are congruent. See, angle 2 and angle 6 are both in the top right corner of their groupings of angles. Angle 3 and angle 7 are corresponding angles. So they have to be congruent. And angle 4 and angle 8 are corresponding angles. So they're congruent as well. Okay, corresponding angles in the same position. And the reason they have the same measurement is because these lines are parallel. The transversal is cutting through those two parallel lines at exactly the same angle. And so you end up with these same angle measurements here in the corresponding positions. Next, we have alternate interior angles. Now remember, interior angles are the angles that are inside of the parallel lines. Lines B and C are parallel to each other. 2, 3, 5, and 8 are the angles that are inside of those parallel lines. So the interior angles are 2, 3, 5, and 8. Alternate just means they're on opposite sides of the transversal. Here's your transversal, A. Angle 3 and angle 5 are interior angles, and they're on alternating sides of the transversal. They even look like they're the same measurement, and they are. Angle 3 is congruent to angle 5. Now, the other pair of alternate interior angles would be angle 2 and angle 8. Angle 2 is congruent to angle 8. Okay? And if somebody says, well, how do you know angle 2 is the same as angle 8? You say, well, they're alternate interior angles, and alternate interior angles, by definition, are congruent. They have the same measurement. Sometimes people will ask, is there such a thing as alternate exterior angles? Yes, that is a thing also. We don't talk about them as much. But if you want alternate exterior angles, they would be exterior because they're outside of the parallel lines. Angle 1 and angle 7 are alternate exterior. Angle 4 and angle 6 are alternate, meaning they're on opposite sides of that transversal. Exterior, meaning they're outside of the parallel lines. They are congruent as well. 4 and 6 look the same measurement, and they are. They're alternate exterior angles. But usually we just talk about alternate interior angles. And then adjacent angles, we discussed these yesterday. Adjacent angles are the angles that are right next to each other. They share a common side, they share a common vertex, but they don't overlap each other. Okay? Now, adjacent angles are not usually congruent, not unless you have right angles, not unless the lines are perpendicular. But adjacent angles are special because they're supplementary, meaning they total 180 degrees. Let's name some pairs of adjacent angles. We're not going to name all of them. Angle 1 and angle 2 are adjacent. They're right next to each other. Angle 1 and angle 4 are adjacent. Angle 3 and angle 4 are adjacent. Angle 6 and angle 7 are adjacent. Angle 6 and angle 5 are adjacent. They're right next to each other. Angle 5 and angle 8, are you getting the idea? Those are adjacent angles. And adjacent angles are always supplementary, meaning they total 180 degrees. Man, that's a lot of terms. All right, so finally, let's find all the missing measurements in this figure. I'm given one measurement, this one right here, it's 32 degrees. Can you give me another measurement? How about angle 1? That has to be 32 degrees. How do I know? Well, because these two angles are vertical angles, and vertical angles are congruent. How about angle 5? That has to be 32 degrees also, doesn't it? I may as well circle this one since it's a known measurement. How do I know angle 5 is 32 degrees? A couple of ways. One way is because these two angles are alternate interior angles, which have to be congruent. Alternate interior. I also know this is 32 degrees because angle 1 and angle 5 are corresponding angles. Remember, corresponding angles are congruent. They're in the same location in their individual groupings of angles. So there are a couple of ways I know that's 32 degrees. So that means angle 7 is 32 degrees. I know so because it's vertical to angle 5. I also know so because it's corresponding to this 32-degree angle. And I know that angles 1 and 7 are alternate exterior angles, so they must be congruent as well. I've actually found all of the acute angles to be 32 degrees. So I have to do something different now to find the obtuse angles. And what I have to do here is I have to use what's known as adjacent angles. Angles 1 and 2, for example, or this 32-degree angle and angle 2 are adjacent. They're right next to each other. And remember, that means they're supplementary. They total 180 degrees. So if I want to find angle 2, I could just take 180, subtract 32, and let's see what we get. Make this 8 a 7. This becomes 10. 10 minus 2 is 8. 7 minus 3 is 4. And I have that 1 out in front. So 148 degrees. So angle 2 is 148 degrees. Well, I just unlocked the puzzle, didn't I? So angle 4 has to be 148 degrees. Why? Well, because it's vertical to angle 2. Because it's adjacent to this 32-degree angle, so they have to add up to 180. It's adjacent to angle 1, so these have to add up to 180. Lots of ways I know. So angle 6 is 148 degrees. It's corresponding with angle 2, so they have to be congruent. It's alternate exterior with angle 4. And angle 8 here is 148 degrees as well. Lots of reasons for knowing that. 6 and 8 are vertical angles, meaning they're congruent. 8 and 4 are corresponding angles, meaning they are congruent. 8 and 2 are alternate interior angles, so they have to be congruent. And you see these 8 angles are one of 2 measurements. There are only 2 measurements in this entire figure, 32 degrees and 148 degrees. So many terms. That's the end of the lesson for today. I'll see you tomorrow.